Good morning. Any questions from yesterday's class? Any doubts? If if you don't have any doubts, please raise your hand.
Good morning, sir.
Okay. So shall we proceed ahead? So let us do today error analysis. Now this is a very crucial thing because it is one of the favorite topics of JEE mains and even JEE advanced also. Questions are asked from this topic. So instrumental, so errors whose causes are known to us. Example, instrumental errors which may be due to erroneous instruments. So we just saw yesterday also that how zero error can occur in both the vernier calipers and also screw gauge. Okay, so these errors can be reduced. Okay, by using more accurate instruments, applying zero corrections, and whenever it's required. And sometimes the errors they may arise on the account of ignoring certain facts. For example, in measuring time period of simple pendulum, error may creep because no consideration is taken of air resistance. These errors can be reduced by applying proper corrections to the formulas used. And also, like many a times when we have experiments, when we conduct experiments, so there also errors will occur. And many times we don't uh, account for certain facts which are there, and due to that also errors may occur. Change in temperature, pressure, humidity, etc. may also sometimes cause errors. Now the errors uh, which like which is like, for example, due to parallax means like uh, I am observing the vernier caliper. Okay, and instead of like seeing, like if you see from here, you will find sometimes you will find different division coinciding. Okay, so it's something a little bit here and there may occur. Or like, for example, if we are finding the time period of the pendulum, so then in starting and stopping the stopwatch, again, few microseconds or milliseconds we may go here and there. So that also is a cause of error, but that is a random error. Okay, and such random errors, in order to reduce these random errors, we have repeated observations. We have to take repeated observations a number of times, and we take the arithmetic mean of all the observations. The mean value would be very close to the most accurate reading. Okay, so as we can see here, so we have taken many readings, and then the mean value is going to be the average of all the readings, and this is reported as the the overall value of the experiment. Now, for example, let us say we are conducting an experiment. So this is not the first slide. This was the first slide. First slide, like we just talked about different errors due to instruments, and even sometimes due to atmosphere. Okay. So now let us take for an example. We want to find out acceleration due to gravity. We know that acceleration due to gravity is 9.8 meter per second square. Okay. So now let us say student A performs an experiment and the student A gets these readings 9.7, 9.8, and 9.9. You will find that the average is 9.8 only. Then the student B does the experiment and student B gets 7.8, 9.8, and 11.8 meter per second square. Here also you will find that the average is 9.8 meter per second square only. Now, which student is better conducting the experiment? Because both of them, they are getting averages same. So technically, the first student is having a better setup and is performing like better experiment than the second one. Why? The reason is that you see from the average, the readings of each observation is differing very less for the first one. So it's like 0.1, 0, and 0.1. But for the second one, it is differing by, you see, 2, 0, and 2. So therefore, the first experiment is better. Okay, uh, and therefore we uh, like therefore we add on something more than average, which is error. Now, how to find that error? Okay, so what they're telling is, so we get a mean value. Okay, we'll write it again. It was 9.7, 9.8, and then 9.9. So the mean value was 9.8. Now, how much it is different from the mean value we calculate. So delta x we calculate. So it is different by 0.1, it is 0, it is different by 0.1. Now the average of the mean values, average of the deviation of the values. Okay, this is 0.2 upon 3. So therefore, the acceleration due to gravity will be reported as 9.8 plus minus 0.2 over 3. This is for student A. And for the student B, it is 9.8 plus minus. So it was 7.8, 9.8, and 11.8. So 2, 0, and 2. So the average is 4. So therefore 4 upon 3. So as you can see here, the error is more in case of student B. Error is less in case of student A. So therefore A is a better, A is performing the experiment better. If it is clear, please raise your hand. Suchita. Yes. So we have to find the difference. Okay. Not like, for example, the difference between 7 and 8 is 1. And the difference between 8 and 7 is also 1. Okay. So that's why you see they have mentioned that like later on it will come the absolute error, which is mod of that. Okay. Is it clear? So we have to find the mod of the error, the absolute value or the deviation, how much it is apt. Okay, if it is clear, please raise your hand. We'll proceed ahead. Okay, good. And then final result, we report it, A mean plus plus minus delta A mean. Okay. And then we can write it as a relative error also. We can write it as percentage error also. So like for example, for the first one, which was 9.8 plus minus 0.2 upon 3, and the second one it was plus minus 4 upon 3. So here the relative error will be 0.2 divided by 3 divided by 9.8. Here it will be 4 by 3 divided by 9.8. So this is the relative error in both of them. And percentage, we just multiplied by 100. Solve this.
Excuse me, sir. Could you show the slides from absolute error again? I didn't get to copy the entire thing.
Pardon?
Could you show the slides from absolute error again? I didn't copy some steps.
I will, okay, I'll just, like right from the beginning, I'm showing. So this is the, um, okay, systematic error, okay. This is random error.
Yes, sir.
Then there is absolute error. So we calculate the deviation from the mean value of each individual observations recorded.
Yes, sir.
Then we have this as the delta A mean, like the deviation. We find the absolute value of the deviation and then we find the average of that.
Yes.
And then we report it like this: mean value plus minus delta A mean.
Just a second. Thank you.
And this is the relative error in the percentage.
Done. Thank you.
Clear?
Yeah.
Okay. So we'll go one by one. First, find the A value, mean value, and then send it. This is the mean value. So, like yesterday, we had understood that when there is addition, then how do we round off? We round off to the nearest, not, yes, we round off to the decimal place, the least decimal numbers. What, uh, like, the input values are having. So here we have 3. So therefore, the answer also, it should be rounding off to 3 decimal places. So just see again whether you're getting this. If yes, please write and send again. Good, good. Okay. Suchita, did you get the exact thing? Just let me know. Good, wonderful. B part. Find the absolute value, absolute error in each measurement. Find out. So basically, you have to kind of find the difference between the mean value, which we got 2.626, and each individual values. So do B and C. Okay, find C and B. Mean absolute error 0.003. Well, not 0.026. It's 0.0026. Just check this again. Then the fractional error. Find out the fractional error. So fraction error is going to be 0.001 because it's delta A mean divided by the mean value. If it is clear, please raise your hand. And then find the percentage error. If it's clear, kindly raise your hand. Got it? Okay. Then find the percentage error and the results we have to express it in terms of percentage error. Yes, that's correct. Good. Now we proceed ahead. Error in addition or subtraction. So when we have x equals a plus minus b, then and like a also has error, b also has error in it, then the error associated with x will be delta a plus delta b plus minus that. Okay, like for example, let us say there are two distances which have to be measured, which are measured. Okay, so from station A to station B, and then station B to station C. So this is, let us say, 10 or 100 meters plus minus 2 meter, and here it is 50 meters plus minus 4 meter. Then the total distance d will be equal to, so we add both of them, 100 plus 50 is 150 plus minus the errors will also get added, 2 plus 4 which is 6 meters. Okay, now why the errors get added? You see, so when we write it is 100 plus minus 2 meters, so that means it can be from 98 to 102, and this can be from 46 to 54. So if both are, let us say, the least values, so then it becomes 98 plus 46, which is 144, to 102 plus 54, 156. So therefore this is the same as 150 plus minus 6. If it is clear, please raise your hand. Good. Now even in subtraction also it will get added only. Okay, solve this. Perfect. Is it clear? Good, good, very nice. Errors in product. Now, this is important. Okay. So errors in product, errors in division. So both of that, we will be combining both of them in a generalized situation where we have error in quantity raised to some power. Okay. So what we do here, we write here, let us say, x depends upon a to the power p, b to the power q, and we divide it, so c to the power r. Okay. So we take ln on both the sides, logarithm. So ln x is equal to p ln a. So okay, I'll let you know. So ln a into b is equal to ln a plus ln b. Okay. So therefore we can write ln a to the power p plus ln b to the power q minus ln c to the power r, because ln a by b is equal to ln a minus ln b. Then ln a to the power b will be equal to b ln a. So therefore this becomes p ln a plus q ln b minus r ln c. Is it clear till now? Please let me know. If yes, please raise your hand. I have just simply taken ln on both the sides. Now we differentiate on both the sides. So this becomes dx upon x is equal to p into dA upon A plus q dB upon B minus R dC upon C. Now dA, dB, dC and dx, these are all, keep it in mind, these are all small errors, not big errors. Small error means like till 5 to 10%. This is a small error. So therefore we have the error in the error percentage in x, we can write it like this. Okay, please note it down. Okay, this is how we are going to calculate, and you will find this question coming up repeatedly in JEE mains and even JEE advanced also. If it is clear, please raise your hand till now. Corey? If not, please ask question. You can write, or you can like, okay. Once you have written, please raise your hand, then I will move to the next slide. If you have written, please raise your hand. Suchita, have you written it? Good. Now we do this one. So this one I will do for all of you. Okay. Mass and density of a solid sphere are measured to be this. Calculate the volume of the sphere with error limits. So volume is going to be equal to mass divided by density. Okay. So we take, what about errors more than 10%? I will tell you. I'll tell you. So V equals M by rho. So we take ln on both the sides. So ln V is equal to ln M minus ln rho. Differentiated, dV by dV is equal to dm by m minus d rho by rho. Okay. So we have dV is equal to V into dm by m minus d rho by rho. Now let us calculate V. V is going to be 12.4 kg divided by 4.6 kg per meter cube. Gone. So this is 12.4 divided by 4.6. It is 2.69. 2.695 meter cube. But we have to write it down in two significant figures because the least number of significant figures have to be recorded. So this is going to be 2.7 meter cube. Okay, so this is V. So now dV will be equal to 2.7 into dm by m, which is 0.1 is dm by m, which is 12.4. And here we have to do plus. Now why we have to do plus? Because d rho, we can take it as minus 0.2. Okay, in order to maximize the error. So therefore it's going to be plus. So 0.2 divided by 4.6, which is going to be plus 0.2 divided by 4.6 multiplied by 2.7, 0.139. So this is 0.14 meter cube. So therefore it's going to be 2.7 plus minus 0.14 meter cube. Is it clear? If yes, please raise your hand. Okay, good. So this is how we'll be calculating the error. Yes, if error is huge. Okay. Anyway, I'll be sending you the slide. So, and it's mentioned there. So, if you want to write down, you can write down also. Fine. If you want, you can write it down. After writing, please raise your hand. Good. Yes, if the error is huge. So let us say that in this only, okay, we take a convenient thing. Okay, so mass is 10 kg plus minus 5 kg. Okay, and density is Let us say 1 kg per meter cube or 2 kg per meter cube plus minus 1 kg per meter cube. Okay, so we have volume as mass divided by density. So if we do by the differentiation method, dv by v is equal to dm by m plus d rho by rho. So therefore dv will be, so volume, which is 5, dm by m 5 by 10 plus 1 upon 2, which is 5 into 1, which is 5 meter cube. This is dv. Is it clear till now? Please let me know if raise your hand. Okay. So now volume is like 10 by 2, which is 5 meter cube. So we will report it as 5 meter cube plus minus 5 meter cube. Okay. But actually, this is not going to be the answer. How we have to calculate now is, so now we do find the maximum mass. So mass is varying from 5 to 15 kg, and the volume, the density is varying from 1 to 3 kg per meter cube. Okay, so therefore the volume will vary from, okay, so the lowest volume is going to be 5 by 3 to the highest volume is going to be 15 by 1. Okay, so lowest volume will be when mass is lowest and volume is density is highest in this case, and highest volume will be when mass is highest and density is lowest. Is it clear? So this is how we will have to report, not this. And by calculus, anyway, dv means small only, dx means small only. If it is clear, please raise your hand. Just note this down. Write it down, and after writing, please raise your hand. Then we'll proceed. Is clear? Please raise your hand. If you have written, please raise your hand. We'll proceed. Good, good. Okay, we have just 10 minutes left. So instead of doing like general question, let us do questions which have been asked in JEE mains. What do you feel? Yes, this is a JEE mains question. Please solve this. Let us see. This is the answer. So in this case, see, when radius is given, so we have to convert into an appropriate formula which has also the radius in it. So that's why you see here we have converted it into a rho L by pi r square. So therefore, the density is the resistivity becomes r into pi r square by L, and therefore when we take ln, it comes out to be this. Now we differentiate. So differentiating, they all of them they come in their powers, and differentiation of pi will result in 0 because it's a constant, so it doesn't vary. So therefore that pi is like it comes out of the equation. And then once we get this, so we can easily now, we can find it out. Okay, by multiplying with 100, so percentage error. Just calculate for yourself and check whether you're getting the exactly the same thing. If it is clear, please raise your hand. Gauri, if it's clear, kindly raise your hand.
Yes, sir, but I'm still doing the calculations.
Okay, fine. I'll just mention here, see, this is dr, this is r, this is, error in resistance, this is the resistance, this is the error in length, this is the length, and all these errors you will find they are less than 10%, less than equal to 10%. So therefore we can apply this formula. Okay, so what I will do is I will share the PPT, and also I will share a file where JEE mains questions are there, and like one slide will be there when where I have also solved it. Okay, so go through that, and I will also send you homework. Yesterday, like yesterday for screw gauge and vernier calipers, so that PPT also I will send along with homework for that. Okay, wish you all the best. Take care. Bye. Yes, please ask. Yes, please ask and out. Example 2 and 3 of significant figures. Example 2 and 3 or exercise 2 and 3? Example. This one and this one. Can you let me know this question? Sir, in solved examples. Unsolved example. This one. In a PDF which I had sent after the class. This one. Okay. Okay. So we do this. Example. So round off this to 4, 3, and 2 significant digits. So for 4, so this is the fourth 4 significant digits. Okay. Yes, it should remain unchanged. That's true. It should be 231.4. Yes, that's correct. AB by C. So we have this 2270 7472, and we have least significant figure is 3. So we have to round it off and make sure that there are 3 significant figures. Okay. Now the question is, what I asked is that why 227 cannot be the answer. No, 227 is not equal to 2270. Okay. So it can be 227 into 10 to the power 1. This we can write down. This is a valid answer. Okay. And even 2270 also is a valid answer. However, mostly this is the standard format in which the first, like in which this is in between 1 to 9. Okay. And like the first digit. Okay. And there is decimal and there is 10 to the power something. Okay. So any number can be expressed like that. Like for example, if you see this, so this can be written as 7.284 into 10 to the power minus 2. So any number can be expressed in terms of the first digit can be between 1 to 9 and the rest can be after decimal place, and we can put 10 to the power this. 10 to the power this is not counted in significant digits, and this, like both of them combined, they will be counted as significant figures. Is it clear? Okay. Wish you all the best.